that we have the tail number of the aircraft, OY Golf Echo Foxtrot. In this particular configuration, we don't have it with a WAP key, so it's not enabled, so anybody at this point can just walk on and get the hotspot without a password.
So I can log on with my own device right now?
You can log on right now.
Cool.
In fact, you can tweet while you're doing it right now.
I will do it.
So
no WEP key?
This particular configuration that we have, but you can set it up with a WAP key. So this can be fully secure. You can pull up to the ramp, and rest assured you could be doing any applications, and when you have the WAP key enabled, you wouldn't have to worry about somebody coming on and logging on to the Wi-Fi network. Obviously what we're using is the Aviator 200 system on board the aircraft, and we're using the Swift Broadband 200 service, Inmarsat's Class 15 service. It's set at a maximum of 200 kilobits per second. It also comes simultaneously with a single channel of Ambi2 voice. So think of that as 3G standard voice at Iridium cost, so $1.49 US per call. So it's not only an inexpensive system to install, but it's the cost of operation is a big aspect. And this is something that, as we talked about before, changing the mindset of what people think about Inmarsat services. I like to tell people, think of this, 2 years ago, to get 128K of dial-up data would have cost $500,000. Now you can get 200 kilobits of IP data, plus simultaneous voice, installed for under $75,000 US. That is a huge sea change.
Now, in terms, Andy, of what we have on this aircraft, what does the total fit add to weight?
The entire system.
Everything, all the boxes?
Yes, all the boxes. And again, the system is only 2 LRUs. The 2 MCU Swift Broadband unit, which has the integral Wi-Fi and router built into it, and the HLD, and then finally the antenna. And that's really the thrust of what the entire system is. Everything else we're talking about.
Remind me?
It's a high-powered amplifier, low-noise diplexer. It's a what we call a flat pack design. It's less than a quarter MCU in volume.
So taken all together, they add up to
less than 13 pounds.
Wow.
And that's including, now if you had an IGA antenna, that would be a little bit more. But we're talking about wiring, handsets, everything else that it could be. You're talking about 13-pound signal.
So the cabin includes a couple of small antennas somewhere tucked in?
Yes, exactly. They're very small, discrete antennas.
What's the speed?
Right now...
I'm on right now, so I'm kind of testing it, but could we do a speed test on your iPad? That would be great.
We can.
I think just to add to that angle...
Let's see if we can...
there's a speed and there's a perceived speed.
Yes.
Right.
And I would say that most people would be positively surprised about the perceived speed compared to the real speed, because it takes a while for the Inmarsat system to somehow regulate the speed.
I think the important part of this is to say the performance is there, but today it's about talking about applications. When you walk on board the aircraft, you want to stay connected on the ground, and you want to be in the air for an hour and a half. You've got your smartphone. If it's doing everything you want it to do for you, a number will never come in to the conversation.
Right.
So right now we have a download of 158 kilobits, upload of 3 in this one. The application and what it does for you, I think, is more important than the discussion on absolute numbers, because at the end of the day, if you get your application up and running and you get your file downloaded in the time that you want it to, the last thing you're thinking about is, well, did I get that done with 400 kilobits of data or 200 kilobits of data? So I think they'll find the performance for what we're positioning the product for connectivity with your smartphones, for staying connected on those hour and a half flights, simultaneously using voice and data, all in one system. I think they'd be very happy with this.
Yeah, certainly for the size aircraft we're on.
Exactly.
Yeah.
How long did it take to put the installation into this aircraft? and we'll give you some slack for the, you know, the more you do, the quicker it gets. But how long did this installation take? This is a bit of a prototype installation, isn't it?
This was actually, no, this was an STC installation on this aircraft.
Right.
So this was not...
But it was the first of its kind, was it not?
It was the first STC of Aviator 200, but it was not done in an experimental mode. This was an actual EASA STC that's been completed on this aircraft. Yeah. Could be done in a day.
It could, okay.
You know, provided the headliner is out of the aircraft and they can bring the wiring. It's a very straightforward installation from that.
So for kind of higher bandwidth functionality, are you compressing a lot of things?
No, actually, our system is not doing any compression at all.
Okay.
There are ways that you can do that.
Yeah.
There's from the service side.
Sure.
Some of the service providers actually provide some compression services.
Right.
You could put an external router on board that does compression and acceleration. But you know, we don't see, for the value proposition of this system is that it really wouldn't be. It would kind of destroy a little bit of the value proposition of putting on a very expensive external box.
Sure, sure.
Just real quick, I'll just show you a couple things of. I know that we did a speed test, but just.
Mary's on the. This is what happens when we were flying down here. We are sitting back and doing our emails and VPN and stuff, and then someone, it's going a little bit slower, and then Lars is sitting up in the front of the aircraft, also being on Wi-Fi and starting doing some stuff. So it is even in a small environment like this, you can easily have 2 or 3 guys doing something at the same time, and that's when we come to this whole speed experience.
Have you got any sharing intelligence built into the system?
Just use it.
Sharing.
A fair share algorithm, because people liked connection by Boeing.
Yeah.
At one point they said, look, you know, we can't have one person downloading a movie and screwing everybody else up.
And that is a function again of Inmarsat. From the I4 satellites, you have spot beams, and whoever's in that beam is going to share that data. That has not changed any from Class 6 or Class 7 Swift broadband service. So that's
so there's no formal provision in Aviator 200 or.
No. But
there's a limitation on the number of users you can have on the Wi-Fi or the router, but that's not a function of the service per se.
Okay. I mean, the key question is, how robust is the whole thing in terms of the link always being there? Now, I know, of course, that's a function of the satellite operator, of course, and the wider system, but what can you say to us about constant availability? You know, as an ordinary home user, occasionally I lose Wi-Fi access, and I never know why. You know, it's the ISP or it's the ADSL line provider, and it's completely maddening. Now, of course, if you're habituated to this in the air and you start to get spotty coverage, you're going to get very cross. You don't mind it being slow by terrestrial standards, but you want it to be there. So what can you say to us about robustness?
I believe, because this is something I have experienced myself also, is that a lot of the interference you get back home is caused by other people using similar channels. The neighbors, somebody else are using something, some other device.
Yes.
You wouldn't experience that in an aircraft.
Yes.
There's only the users who are on board this aircraft.
Yes.
For the same reason, for instance, we don't have a secure SSID that we use up here, because nobody else will be able to tap whatever we're doing. So my experience with using the system on board the aircraft is that the only time when you get a deterioration of the throughput, apart from the fact that many people may be using the equipment at the same time, is if the spot beam itself is heavily occupied by Inmarsat, which means by other users, then you will have a slower throughput, but you will never experience a situation where you don't have a connection. And the same thing, for instance, with the phone line. I used the phone a couple of times on the way down here, and you may have a quality which is not absolutely perfect, but you never experience the dropouts that we all have got used to on an ordinary GSM phone. You never have that.
So there's latency, though.
I don't feel the latency. It depends, of course, on who you're talking to. If you're talking to somebody who wants to interrupt you all the time, it may be a little bit disturbing. But with some, if you're organized, it's never a problem.
Right.
So you can say to us, hand on heart, that you you never have any sense that this connection is in any way fragile. It might slow down, the voice quality might be compromised to a degree from time to time, but you never feel as though it's gone and I don't know where it's gone.
Exactly, that's for sure.
So you're confident.
And regarding the voice quality, I will say you never experience dropouts, Mickey Mouse talk as you have in an ordinary GSM phone. You never have that. The only degradations you can have on voice connections is actually depending on the type of interconnection you have to the international network on the ground station. Can be some. We all know if we make long haul calls, sometimes we get more and sometimes we get less echo on the line. And if it's disturbing, we just place a new call and then the echo is gone, typically. But that has nothing with the satellite link to do as such.
The two of you are competing for bandwidth.
Yeah.
We all are, aren't we?
Yes.
I'm doing the.
And
I'm trying to show you.
Number
I'm trying to show some practical applications.
And the funny thing is that, for instance, during the flight down here, because I'm flying the aircraft, I'm sitting up front. I have an iPad, and I use it to check the weather information.
So like electronic
en route.
flight bag.
I check weather charts, and I even call telephone numbers where I can get the airport information. In Switzerland, all airport informations from airport are you can dial them on an ordinary telephone and get the airport information. You don't have, so when you're out of reach of the airport, you can still dial the number on the satellite and you get the ATIS as it's called. Directly, so all this type of information you get.
So you use the link to squirt flight useful information into an iPad that you're using.
Exactly, yes.
Lars, are you able to put the approach plates on yet?
Oh yes.
Okay.
I have Jepson approach plates on
So you
my...
do. So you're using it as an EFB, essentially.
Essentially,
Getting
yes.
close.
It's getting very
Getting close.
Essentially, I would say I don't have to make load sheets and that type of
Right.
thing. So, but in terms of weather information and Jefferson chart information and so on, I use it as an EFB. I would say it's even better than that.
Okay.
Because I actually, I haven't got it with me. It's in the building, but I take all sorts of information.
Cool.
That's Jefferson weather you have there.
Yeah.
Yeah, it's the same thing. I can also download that.
So, just out of interest, with your iPad, how do you actually operate with it up on that flight deck? Do you have some sort of, just on your knee? Do you have a knee board?
No,
There's all sorts of kit.
Right.
No,
So it's a class
You don't
one.
believe in knee boards? Or?
I do, but this is not an aerobatic plane.